Welcome back. Now we're going to be talking about how to solve exponential equations. So there's a couple of different ways we can solve exponential equations. These ones are all set up so that we can do them the easier way. And it's best to just get started with the example. So here we go. The first example is 2 to the power of x plus 1 is equal to 2 to the power of 4x minus 2. So in an exponential equation, your x or your variable is up in the exponent. Unfortunately, we can't solve it while it's up in the exponent. We have to bring it down. But in order to bring it down, we need to get rid of the base numbers. And these 2's right here, this one and this one, I like to call those base numbers. And so what we need to do is get rid of those. Now, this is actually really easy because if the base numbers are the same, we can just automatically get rid of them. So in this case, because these 2's are the same, I can just cross them out. And then what happens is the exponents drop down in their place. So now this just turns to x plus 1 is equal to 4x minus 2. And now we can solve it like a normal equation. So let's do it. So to solve this for x, what I'm going to do is subtract this x from each side. And I'd end up with just 1 is equal to 3x minus 2. Then I'm going to add 2 to each side to get the x by itself, which would give me 3 is equal to 3x. Then to get the x by itself, we're going to divide by 3 on each side. We end up with 1 is equal to x. So I know that x is equal to 1. That's my answer. Hooray. Potentially I could plug it back into the original equation and make sure that that works. But I can tell you that it will work. So now the next example is a little bit different. We're going to have to do a little bit more work. It's 3 to the power of 5x plus 1 is equal to 9 to the power of 2x. So once again, we want to get rid of these big base numbers. And last time they were both the same number, so we could just cancel them out right away. In this case, they are not the same number. So we need to get them to be the same number. And the way that we're going to do that is with exponents. So normally we like to, it's easy for me to say, well, 3 and 9, I can just multiply the 3 by another 3 to make it 9. But we don't want to do it that way. We want to do it with exponents. So the way that I'm actually going to do it is I'm going to say that, well, I know that 9 is the same thing as 3 squared, right? 3 squared is equal to 9. 9 is equal to 3 squared. So what I can do is I can replace this 9 with a 3 squared. So what I'm going to do is rewrite the left side because I'm not going to touch the left side. But on the right side, I'm going to replace the 9 with a 3 squared, which makes it 3 squared. But then that 2x is still there. I'm just going to put it in parentheses and shove it next to the 2 from the 3 squared. And it still says the same thing. It's just in a different form, which is totally fine. Because now you have the same base numbers. They're both 3's, which means I can cancel them out. And the exponents drop. So I'm going to have 5x plus 1 is equal to 2 times 2x. Notice that the original exponents just didn't drop. You had to take the 2 from the 3 squared with it. And this is because we needed to change those numbers to be those base numbers to be the same. So now let's just simplify that a little bit. 5x plus 1 is equal to 2 times 2x is 4x. So then let's solve for x. I want to get the x's together first, so I'm going to subtract 5x from each side. I'd get 1 is equal to negative 1x. Then to get x by itself, I divide by negative 1. And I end up with negative 1 is equal to x. So x is equal to negative 1 is my answer. Once again, you could potentially double check that by plugging it into the original equation. All right, let's go to the next example, which is 4 to the power of 4x is equal to 8 to the power of x minus 2. Now, in the last example, we only had to change one of the base numbers, which was totally fine because we knew that 3 squared was equal to 9. But now we have a 4 and an 8. And even though I can say, well, 4 times 2 is 8, we want to use those exponents like we did last time. And the smallest exponent I can use is 2, right? So 4 squared is 16. It's not 8. So when that happens, what we're going to do is we're actually going to change both of these base numbers. We're going to change them to be powers of 2. So I know that 4 is the same thing as 2 squared. And I also know that 8 is the same thing as 2 cubed. So now I can replace the 4 in my original equation with 2 squared, and I can replace the 8 in the original equation with 2 cubed. So when I rewrite it, I'm going to have 2 squared, but then I'm going to just kind of chuck that 4x next to it, equals 2 cubed instead of 8 times x minus 2. And once again, your base numbers are the same, so we can cancel them out, and the exponents drop. So you have 2 times 4x is equal to 3 times x minus 2. Now let's simplify that. 2 times 4x is 8x. I'm going to scroll up a little bit. And then we're going to distribute the 3 inside this parentheses. So 3 times x is 3x. 3 times negative 2 is negative 6. Then we're going to solve for x by getting the x's together. I'm going to subtract 3x from each side. So 8x minus 3x gives me 5x equals negative 6. Then we divide each side by 5. We're going to end up with x is equal to negative 6 over 5, which is my answer. Okay. One more example here. So this example is, sorry, it takes me a second, 625 to the power of x is equal to 25. Now, these ones are both powers of 5, but 625 is actually, we can get away with just changing the 625 because 625 is the same thing as 25 squared. And so I'm just going to replace the 625 with the 25 squared. Now, remember on all of those rules of exponent things, like when it doesn't have an exponent, we put a 1 there. We can also just put a 1 on this 25 over here because it doesn't have an exponent. So now we can cancel out the base numbers because they're both 25s. And we would have 2 times x is equal to 1, which is the same thing as just saying 2x is equal to 1. Then to solve for x, we divide each side by 2. And we get x is equal to 1/2, which is our answer. And there we have it, how to solve exponential equations.